Hello everyone, welcome to SM Tech World. Today we are going to solve another LeetCode problem. The problem name is keys and rooms. So if you have not read the problem statement, you can probably stop the video and go through the problem statement. Then we can start. But yeah, I can just basically brief you the description. Let's go through the example basically. So basically they are saying that we will get like a 2D array or a kind of nested list where each index is kind of a room, right? We need to, like, here you can see, like, here my room length, right, or list length is 4, right? That means I have total 4 rooms, but it will be indexed based from 0 to n minus 1. Okay, now each room will have some keys. So suppose I enter in the room number 0, I may get or may not get some keys, right? So if I get some keys, suppose I get a key of room number 1, I can visit the particular room number 1, right? Now again in the room number 1 I will get some key. It can be like self key, or it can be, there can be key, there may not be key also, right? So basically after executing all the rooms, right, or all the possible if we can traverse or if we can visit all the rooms, then you need to return true, else we need to return false. Okay, so that's the basically that's the nutshell of the problem. Okay, so we can go through the example once again to understand, right, how this is working. Like we can take with the this first example, right? Fine. Okay, so what we are doing here, so we need to assume that we will always start from the room number 0. So we will have, by default we will have the key to go into the room number 0, correct? So I will go to the room number 0, I will get a key to room number 1, because here we have a key for room number 1, right? I will go to the room number 1, then again I will get a key to visit room number, this is the room number 1, right, because it's based on 0. I will get the key to visit room number 2, correct? Fine. Now again if I visit room number 2, so this is room number 2 here, right? 0 1 2. I will get the key to visit room number 3, correct? Now again if I go to room number 3, there is nothing is there, right? There is no key, but we are done with the execution of all the inputs. So after executing all the inputs, I can see I can visit all the possible 4 rooms, correct? So my answer will be true, correct? Now let's see the other example. Okay, the second one, this one, right? So here let's try to draw the same diagram. So we can by default go to the room number 0, correct? This is 1, this is 2, this is 3. So I will go to room number 0. I have 3 options. I can go to the room number 1, I can go to the room number 3. That's true, correct? It's arbitrary, it's up to us. Let's try to visit the room number 1 first. I will go to the room number 1 and I will have 3 key now. Room number 3, right? I can traverse here. Okay, I can go back to 0. Okay, that is already visited. Okay, I have the key, my own key, right? Like kind of self loop. Okay, done. And there is no possible, so there is no room from where we can go from the room number 1, because I already visited 3 0 and 1. Fine, this path is ended. Now we have the another key, right, in the room number 0, that is 3. We will try to traverse from the room number 3. So this is room number 3 here, right? So here we have only one key, that is also going back to 0, correct? So this is the end of our input. So for this particular second input, right, we are not able to traverse the room number 2, correct? We will not be able to traverse room number 2. So our answer will be false here. Okay, because we are not able to visit all the rooms. So this is the basically basic description. Okay, now let's see how we can solve this kind of problem. Like if you see the diagram properly, it's kind of a graph traversal problem, right? Basically here a source node is basically room number 0, and you need to see from the source node, can we traverse all the possible other nodes or not, right? Can we reach to all the nodes or not? So basically it's a kind of graph traversal problem. So basically there are multiple algorithms to solve this kind of graph traversal problem. Like one of the ways using BFS, breadth first search, or using depth first search, or DFS, right, using recursion. So in this particular video we will see the BFS example. Okay, so BFS stands for breadth first search. That means we will pick a node and we will try to traverse all the possible neighbor nodes, right? We will not go to the end of the path, we will just try to visit neighbor nodes at once. Okay, what that means, suppose Okay, so my source is 0, correct, in the second example, right? I can traverse into two neighbor. I will do the level order traversal kind of thing, right? I can go to 1 or 3. I will go there. Now this part is done, right? Now I will try to traverse this particular level, right? So like this we will try to traverse. Okay, now let's see how to solve using BFS, right? So to solve any graph traversal problem using BFS, we need a queue, right? So queue data structure basically, that is fast in fast out. Okay, that means whichever element is inserted, that will be removed fast. Okay, so apart from that, like you can see in this particular second example, right, we can have like self loop, or we can go back to the same room again, right? So there is a possibility, right? So we should not keep looping through the same nodes again and again, right? So for that we will create a visited array. Okay, there I will track whether I visited all the rooms or not, right? Like 0, 1, 2, 3, correct? Now try to see the second example, right? So here we can see like we can traverse from 1 and 3. So what we will do, so by default we can visit room number 0, right? I will make it as true, correct? Now in the queue I will just go try to traverse, right, 1 and 3. I will put 1 and 3 in the queue, and I will also mark 1 as visited because it's already in the queue, right? And 3 is as visited. Okay, now what I will do, we will try to pull or remove the elements from the queue. Queue is fast in fast out, so we will remove the 1 first. Okay, so 1 will come outside of the queue. Now I will try to see from 1 where we can grow, what are the next set of keys I available, that is 3, 0 and 1, correct? So from here I can use 3, 0 or 1. Okay, fine. Now I will try to insert this next set of nodes into the queue. But before doing that, I will make sure that this particular node should not be, or this particular room should not be visited. Okay, so before inserting that room, I will just cross check, is it present in this is visited array? Okay, I will see, okay, 3 is already visited, right? So there is no point of inserting this room in the queue. I will not insert it. I will check 0. 0 is also visited, right? I will not insert. 1, that is also visited, right? I will not insert, correct? So there is no new room we can go from the room number 1. Okay, so we will not insert any records in the queue. Fine. Now I will pop this 3, correct? That is my basically next node in the queue, correct? Now from 3 where we can go? We can go to room number 0, correct? So okay, fine. I will take room number 0 and I will see whether did we visit 0. Yes, 0 is already visited, right? So there is no point of inserting any new records in the queue. So this loop will stop whenever my queue is empty. That means we are done with the traversal. Okay, now it's pretty simple, right? I will just reuse a for loop and try to see, is there any index where the value is false. If there is an index with value is where value is false, that means we can't traverse that particular room, or we can't visit that particular room. So my answer will be false. If every element is true, then it's successful, right? We return true. That means we are able to visit all the rooms successfully. Okay, so this is the plain simple logic. Okay, let's try to see the code for that. Okay, so as I told you earlier, we will take a boolean array. Okay, basically that array will keep track my visited room. Okay, so let's take a array. Let's try to use some meaningful variable name. And what will be my visited array size? It should be same as the room size. We can take rooms dot size since it's a list. Okay, fine. Now what I will do, I will declare my queue first. Okay, so in Java, since I am using Java, right, I will just use the inbuilt queue data structure which comes in the collection framework. So what are the types we are going to insert in the queue? It's an integer value, right? The room number basically, right? Okay, fine. Now we will just initialize it with the help of linked list. Fine. Now I will, so to start the traversal, right, we need some source pointer. So we know in our case our source or fast room is always 0. So I will just insert this offer or add. You can use any of the one method, and I will just offer 0. Fine. Now all the associated rooms, right, we need to check that whether did we visit those rooms or not, right? We'll do that later. Okay. I think, and we need, so since room 0 is already offered to the queue, right, means it's the starting point, right? So we can just mention is visited true for the room number 0. It should be true. We don't basically by default line number 4, right, this will initialize all the index as false by default since it's a boolean, right? So we'll just mark it as true, other values are false. Okay, now we'll start looping through the queue. As I told you, we'll loop until unless queue is empty. Okay, so is empty, we can just check. Fine. If room is empty, then we will stop. If not, then loop will go on. We'll try to poll the elements. Okay, so we'll remove the first element from the queue. It's a FIFO, right? I told you. So int current room. I can use the inbuilt method poll. Okay, that's basically remove the element from the queue and give me the value. Fine, correct. Now what I will do next, I will try to traverse all the possible basically all the possible sides, right, neighbors, right, correct. But before that, we will just try to mark it as true since I already visited this, right? So it should be room equal to true. Fine. Now let's try to visit all the possible neighbors from that particular node. So I can just use enhance for loop here. It can be integer next room, something like this, and I can just take it from the room input rooms list, right? Get index will be the current room. So from this current room, where I can go, right? So that we are trying to see here. Now I will just check, right, before inserting to the room, I will check did we visit the rooms earlier or not. Is visited next room. If it is true, then we will not do anything. If it is false, right, then we have not visited this particular room till now. We will insert this into our queue. So let's do that. Room queue dot offer the next room, that is basically next room number. Okay, that's pretty much, that's our queue logic. Now it's pretty straightforward. We will just go through the input visit array, right? So let's do that. Boolean room is visited. Here I will check is there any room which is not visited. If room is false, that means we have not traversed that room. Return false. Else at the end we will return true. Let's try to run the code. Okay, let's try to run the code and see. Okay, so it's giving us some error. There is a slide spelling mistake here, so it should be room. Now let's try it again. Yeah, you can see it's giving us the correct output for both the scenario. Fine. I think even we can remove this also, right? This is not required because this is like a redundant line, right? So we are already marking it true here, so we can comment it out this also, right? And let's try to see. Yeah, it's giving us the correct answer. Let's try to submit the solution and see. You can see this solution is accepted and it's giving us the correct answer. Okay, so that's how you can solve a breadth-first fudge problem. Okay, correct. So I think that's pretty much for this video. Thanks for joining. If you like our content, you can just try to subscribe to our channel. Bye.